Welcome to an animated explanation of the AES encryption algorithm. AES is a symmetric block cipher standardized by NIST as FIPS 197 in 2001. It encrypts 128-bit blocks using keys of 128, 192, or 256 bits. AES operates inside the finite field GF. Tool: a byte is an 8-bit polynomial. Addition is bitwise XOR and multiplication is modulo an irreducible polynomial. Multiplying by x is a left shift plus a conditional XOR with 0x1b. AES arranges the 128-bit block into a 4x4 byte matrix called the state. Bytes are loaded column by column. The first 4 bytes form column 0. Each column can be read as a 32-bit word. Subbytes replaces every byte using a fixed substitution table, the S-box. The S-box is built from a multiplicative inverse in GF to F followed by an affine transform. This nonlinearity creates confusion in the cipher. Shift rotates each row left by its row index. Row 0 stays in place. Row 1 shifts 1 left. Row 2, 2. Row 3, 3. Only positions change. The byte values themselves are not altered. Mixed columns treats each column as a polynomial over GF to its through. It multiplies the column by a fixed polynomial, mixing the 4 bytes together. This step spreads influence across the column, providing diffusion. Add round key combines the state with the round key using bitwise XOR. XOR is addition modulo 2. It mixes the key material into the data. AES expands the 128-bit cipher key into 44 round key words. Every fourth word rotates its bytes, substitutes them, and XORs a round constant. The remaining words are simple XORs of earlier words. A full AES 128 encryption runs 10 rounds. Rounds 1 through 9 apply all 4 transformations in sequence. The final round skips mixed columns. We encrypt 128-bit block using the standard AES test vector. First, we XOR the plaintext with the cipher key. Round 1 begins with subbytes, replacing each byte through the S-box. Shift rotates each row left by its row index. Mixed columns multiplies each column by the fixed polynomial, mixing bytes. Add round key XORs the state with the first round key. Rounds 2 through 9 repeat these 4 transformations. The final round skips the mixed columns and produces the ciphertext. Decryption reverses each transformation in the opposite order. In fifth shift rows shifts each row right, undoing the left rotation. Invert bytes applies the inverse S-box to each byte. Invert columns multiplies each column by the inverse polynomial. The final XOR with the original key recovers the plaintext. The result matches the block we started with. AES is a fast, secure block cipher standardized by NIST. 4 simple steps repeat to create strong diffusion and confusion. Thank you for watching.